Hey guys, in this video I'm gonna show you this kind of transmitter and receiver and with range of up to 1 kilometers by using this kind of NRF24 module which I have inbuilt antenna, and this is the simplest version. Also it's very cheap as compared to this one. So as you can see, it's a transmitter portion which is based on the Atmega 80 microcontroller which comes from the Atmel company. And also I made a 0 PCB based circuit, and here 3.3 volt regulator for this NRF24 module, and there are a lot of digital pins and as well as analog pins. So here, and this is the receiver of this transmitter, which is based on the Arduino Nano, which is a Atmega 388P microcontroller chip, and these are the pinouts output of this receiver, and it also uses the NRF24 module, and I have made a PCB for this receiver which is very clean, and here you can see it's a 3.3 volt regulator for this NRF24. So let's see the working of this so here it's a 3.3 volt battery for the receiver, and I'm connecting like this. And also for the output notification I am using 4 LEDs, and I have configured the output as the analog pin number 0 to analog pin number 3. So this receiver have 4 digital and 2 analog outputs. Here I am using a 2 LED for the analog output. So it's a D5 and D6, which is a digital pin 5 and digital pin 6 pin of the receiver. So the receiver is completed, and here if I power the transmitter, then the LED will glow. As you can see, and for the controlling I am using this breadboard which has pull down resistors and pull up resistors, and for the connection I am powering with ground, and this is the VCC, and I have configured the digital pin 2 and digital pin number 3, digital number 4 and digital number 5 as a digital input for this transmitter. So here as you can see, when you press the respective switches the output will comes, and for the analog pin configuring, here I am using a 10 kilo potentiometer for the both of the controlling. So as I connecting the A0 and A1 pin of the 8MB microcontroller, and connect the VCC and ground supply. As here if I rotate the pot, then you can see the brightness of the LED is affecting, and this will control the red LED. So the working of very fast, as it have up to 2 Mbps of speed. If I control the both, then the both will work at the same time. That's very good for the controlling of RC car or robot. And you can also use this kind of NRF module, which is also same pin out as compared to this, but this also this have a very long range up to 1 kilometer, but this module also give up to 200 meters of range. So this is the working of this transmitter and receiver. So let's move on the code of this both transmitter and receiver. I'm on the Arduino ID software for the programming of our transmitter and receiver coding. So this you can see it's a 6-channel transmitter code. So for the working of this NRF module, first we have to include a library for the NRF module. So you can see here manage library folder and search for the NRF24 and include this library for the or this project. And here our transmitter portion, the Arduino and NRF module are connected through the SPI communication port. So for which I am including the SPI.h library, and after this you can see it's a address pin for the or transmitter and receiver. So this must be the same as in the transmitter and receiver. So after this I will be including the data pins of which our radio modules will send and receive the data. So I've chosen the digital pin number 7 and 8, and after this I've selected my data pins on which are 6 channels. So I'm using a byte function so that we can store 1 byte or 2 byte. So as shown, the LED1, LED2 and LED6 are configured. So after this here void reset function which will reset the output if our transmitter or receiver will disconnect with each other. So the previous by default value for the is 0, so that it will off or shut down. And after the setup portion we can see here the radio.bing function which will be act as a communication between the transmitter. And after this I'm using 250 kilohertz of speed at which all data will transmit. So this is the 250 kilobytes. And after this I configured the analog pin which used for the map joystick values, and this will adjust this kind of analog input which will be our analog A1 and A2, A1 and A0 pins. So this is for our joystick, and in my circuit I have connected a 10 kilo potentiometer, and you can see it's 4 digital pins for controlling the digital outputs, for which I am including the digital pin 2, 3 and 4 and 5. So this is the transmitter portion, and now let's move on the receiver portion. And after this you can see it's a receiver of 6 channel. So as before I said SPI.h and NRF24 library, and also we can see the address is the same as in the transmitter, and always the data pins digital pin 7 and 8 as same as the transmitter. And here in the setup portion we have configured the output pins which is your PWM pin. So and these are for the digital pins. So the A1, A0, A1, A2 and 3 are both all the digital pins. And after this I've configured the PWM pins which is Arduino Nano pin number 5 and digital pin 6 and digital pin 5 which support PWM output. So I've configured these pins. And here after the configuration, here you can see digital light function for the digital output, and 4 digital output pins digital light function, and 2 of which are analog light function which will make the pins as analog light, which means a PWM signal will goes from 0 to 100% duty cycle. So this is the coding portion of the both transmitter and receiver, and also you can see the working as well. So this is the whole project, and if you have any doubt regarding this coding or circuit, so you can also ask your doubt in the comments, and the details of this circuit diagram and coding is also given in the description. So thanks for watching, and I will see in the next video.